I'm Stephanie Bell. I'm the lead scientist for humidity measurement at NPL. Let me tell you about it. In the simplest terms, humidity is simply water vapour in air. When we want to be more specific about it, we may talk about relative humidity. That describes how saturated the air is compared to how saturated it could be at that temperature. We also talk about dew point or dew point temperature, and that is the temperature at which you would get condensation if you were to cool a gas. The humidity in the air contacts everything we do, so a vast range of processes are affected by humidity, which include all kinds of manufacturing of items which are water sensitive, which includes foods, pharmaceuticals, organic materials, things like pharmaceuticals where medicine shelf life depends on humidity, but also the ability of the body to absorb medicines depends on the action of water on the surfaces of the drugs. So we use our dew point standards to calibrate condensation principle hygrometers. Inside the instrument there is a surface, in this case a mirror, which is cooled until condensation occurs. There's then an optical detection of that condensation. At the same time, the temperature of the condensing surface is measured using a platinum resistance thermometer, and there's a feedback so that the mirror is eventually controlled at a constant thickness of condensation using the optical feedback. So we will calibrate this by supplying it with gas from one of our dew point generators. We compare that to the temperature reading of the instrument, and if there's a difference, we can report that to the customer, and that is the calibration. This supports a lot of calibration labs directly, and then a lot of industrial labs. And through both those channels, we then reach out into industries such as pharmaceuticals, various types of process engineering for high quality manufacturing, electronics, healthcare devices, and then reaching out into things like weather and climate, including climate research, and a particular niche area called environmental testing, where people put products, particularly defence equipment, into a test chamber, maybe like this, only a bit bigger, and cycle it through some extremes of humidity and temperature, either to simulate the conditions it will see in service, or as a powerful tool to accelerate the appearance of failures or flaws in the equipment. We've done some interesting work on devices that measure water loss from skin. Not necessarily just perspiration, but sometimes it's important to know what the barrier function of skin is just to normal transpiration when water simply evaporates through the skin. The interesting thing about that is it's an indicator of skin health. When I'm traveling, I can tell just a little bit what the humidity is without making a measurement, as anybody can. If you have long enough hair and it's available to move, you can feel the static in your hair. I've been to Scandinavian countries in winter, and the hair just is plastered around my face, and I realise why Scandinavian women might wear their hair short or tied back. But also, if you go to hot, humid countries, you don't need an instrument to tell you it's very humid.